sliding into question. So let's see what's inside this question. So first of all, I am reading this question. So you have to understand what are the functionality, what are the use cases. So the question is like 3 to 4 on this LeetCode platform. Okay, and go and check out this question after this discussion. So you have given this question, count the number of substring, count the number of, so we have to return a number. So as a thinking, count a number. So keep in mind, count a number of a substring. Okay. Just like we have sub array for what? For the array. Okay. The same, the substring for the string. So substring with dominant one. So dominant one, if we don't know that thing, so it must be explained here. So okay, you were given with the binary string. Okay, binary string s. So binary zeros and so we have to do all operation on zeros and one. Okay, return the number of substring. Return the number of substring. So you have to return any integer. Okay, return any integer and of a integer number of substring with the dominant one. So like every time you are thinking that what is dominant one. So let's see what's the dominant one mean. Okay. So a string has a dominant one if the number of one in that string is greater than or equal to the square of that number of zeros in that string. Okay. It's mean dominant one is the number of one is greater than, yeah, is equal to number square of number of zeros number of okay, number of one is greater than is equal to square of number of zeros. So this is called a dominant one. Okay. Okay, that's that's a great question. So let's see how I find this dominant one. So as you can see here, we have 0, 0, 0, 1 and 1. So we have number of 1. So the count of 1 is equal to 2 and count of 0 is equal to 3. Okay. So if I want number of dominant substring, so we want number of substring that is condition satisfying. Okay. For this substring, so first of all, thinking is that you have to think of this question. Okay. Brute force approach is like trying every substring and every substring and then you have to check. Okay. So let's see. So let's break down this question fully. Okay. So this is the thing that you have to understand. So let me first of all. So binary means that a string. First of all, binary you have understand dominant one is equal to all this thing. Okay. Brute force thought is like brute force thought for this one is that first of all when a problem asks a count, like count the like count substring that meet condition, the substring, yeah, sub array meet the condition, some x condition. Okay. Okay. So what you think, like beginner like instantly think about how do I look at every, so like how do I look at every possible substring. So explore, then we have to explore all possible substring you have. Okay. So you have to explore all possible substring. So how all possible substring is like how we look at every possible substring. So how you look at every possible. So in that case, you have you have to pick the index I, which goes from 0 to n minus 1. Okay, and pick another index that is j starting with I and go till n minus 1. Okay, so this is how we are checking. Okay, and substring as an and if we like find this substring, then what we have to do? So then how do I check the substring is valid? For the dominant case, dominant case, you have to check. So now the next question is that how I check that substring, how the substring is valid. So I check we have substring starting from I and this ending with j. Okay, valid or not. So you have to check. First of all, I have to count. So in that substring, I have to count this zero, like count zero and count one. Okay, inside the substring. And if we if that if the count of this count of one is greater than is equal to count of zeros square. So it is condition, then we have this condition in true and count we have to increment this. We find that string. So dominant one plus plus. Okay, this is the brute force approach I was thinking about. Okay, and increment the count and like true. Okay, so let's write the code for this one. uh, the code is simply easy. First of all, what we have to return? So we have to return the total count. Okay, so total count, how many that dominant string we have, and we have to also initialize that s dot length. Okay, this s dot length is like a size of that binary string. Okay, now I have to pick every 7. I have to pick every possible starting position of that string. So for a starting position, so int I is equal to 0, I is less than n or I plus plus. Okay, now I have to count the two things, that is like 0 and that 1. Okay, so now expand that loop for the another j that is starting from this ith index. Okay, for finding this thing. Okay, and j is less than n and j plus plus. Okay, so after that, what we have to do? We have to do the counting of this 1 and 0. So okay, so if I see in the string of j is equal to 0. Okay, so in that case, that is substring. That's why I'm using this code. Okay, you have to keep in mind. So in that case, you have to 0 plus plus. Otherwise, else case is that you have to increment 1 plus plus. Okay, so now we have a 0 count and 1 count. Okay, so now we have to check the condition. Okay, so if this 1 is greater than or is equal to this, we don't use like a square or like this thing. Okay, so we can't do in this C++ code. So for that we have to do 0. So 0 multiply 0, this is also a square if it condition is satisfying. So in that case, what we have to do is total count plus plus. Okay, total count plus plus, and finally we have to return this total count, return the total count. Okay, so but the problem in this code is that it won't work for the higher time complexity. Okay, so as we see that this is running in order of n, and this is the nested version and nested code, and this is also running as the order of n. So whole make as a order of n square. Okay, okay. So as we see, if it is like if n is equal to 10 to the power 5, then if n square become 10 to the power 10, so it like won't work for the larger test cases. Okay, and the space complexity, we are not using any extra space, we're just keeping the track of the variable. Okay, so that's why the space time complexity is equal to order of 1. Okay, that's the clear. But we have to optimize this code. So every time we are exploring, so in this we are exploring all this, exploring all possible, exploring all possible substring. Okay, we try to optimize this thing. Okay, we try to optimize all this thing. Okay, so let's see what is optimized version. So optimized version for this one is like so let's see the optimized version. Optimize our version, this one. Okay. So first of all, we we one is that one, and we have to reduce. So like for dominant one, we are checking that one is greater than or is equal to 0 square. Okay, 0 square. So notice how fast this grow. Okay, okay. So we have to count this one. So if we have if we have a 0 is equal to 10, so in that case square become 7. If 10 is equal 0 is equal to 100, so in that case it become 10,000. If 0 is become 200, so in that case it become 40,000. Okay, since the maximum length since the maximum length n is like less than is equal to 40,000. Okay, but 40,000. But if we if all the substring, if all the substring is if all the substring if all are zeros, so if all are zeros, so in that case we have 40,000. Okay, and we have to do square. So in that case it becomes very hard for us to do this. Okay, so valid substring, so we have to reduce all this thing. So we have reduce that thing so into the n1. Okay, root of n. Okay, instead of checking the all the possible position of j over n. Okay, which give of n square, we need to iterate over the number of zeros count from 1 to, so we have to count zeros from 1 to root of n. Why not n? If we count root of n, and if n is equal to 40,000, so we can't do 0 square. So 40,000 into 40,000 square is like very big number, so it can't handle. So we have to reduce the search space from this 1 to root of n. Okay, this is the core thinking for this question. Now so now how we pre-compute all this next zero. So to quickly jump on the 1 0 how we count all this thing. Yeah, so how algorithm look like? So how algorithm look like? So let's think. So this question, I think that what is sliding window approach for this one? Or how I A sliding count at an push. So this is not simple as like earlier problem. So it's not simply done by the sliding window approach. Okay. So first of all, we have to do something. So like algorithm explained that algo look like this one. First of all, handle the zero substring directly. So we have to handle the zero substring directly. So any substring containing only one. So any substring that containing only one is always valid. Is always valid. Okay. And because one is like far greater than zero zeros. Okay. So we count and we store the index of all zeros character, store the indices of all where is a zero character in that array of zeros. So we make a zeros array, and in which we store the indices. Okay, index. Okay. From the starting index, I iterate from the starting index. I iterate over the this z starting from this z up to from the 1 to 1 to z square that is less than is equal to n. Okay, and find the index of that zero after I, and we do this thing. Okay, so what I'm telling, let's write the code and you have to see this thing. First of all we have to, first of all, that is int n is equal to as dot length. Okay, okay, this thing we have to do. Okay, after that we have to initialize a vector, store all the indices of zero. So in this we have to store all the indices of zero, so that's we name as a zero. Okay, now we have to run this loop. So in I starting from 0 to, okay, write it, write all these things. Okay. So for loop starting from int I 0 to I less than n or I plus plus. Okay, this is the case, and in which we have to check if s of I is equal to 0. Okay, so in that case we have to push that index in this 0 vector. Okay, so zeros dot push back what we have to push that index. So in that case I push that index. Okay, now we have to keep the total, we finally want like total count of all these things. So in that case we do this thing, and after that int total count is equal to 0. Okay, and int max, so max 0 for the valid string, max 0 that is valid for this thing is like a square root of this, and we have. Okay, so max zeros we need only this one. Okay, so what we have to do, so after this for loop for loop is finishing here. Okay, so again we write another for loop. So tracking on this 0. So I starting from 0, I less than n or I plus plus. Okay, so find the first 0 that appear after that ith index. So we have to find this first index. So for that one we are using this auto it lower bound. Okay, lower bound in which zeros dot begin and zeros dot end, that is like first index after that one. Okay, so int first 0 is equal to first 0 is like a distance from 0 dot begin. Okay, 0 dot begin to this one. So what is the distance between this one? Okay, so we find a distance of this one and we store. Okay, and now the substring will substring with a 0, and now we have a substring with a 0. Okay, so now we have to check for loop. This is the out. This is not out. This is the inside that loop. Okay, 0 starting from 1, and 0 is less than max of this 0. Okay, and we have to see the current position of that 0. Okay, so first 0 plus that index minus 1. Okay, this is the current position of 0. So if the current, like if the current position of 0 is greater than is equal to 0 dot size, 0 dot size, so 0 dot size, so we have to break that. Okay, because if there is aren't a 0 remaining after that index, we have to stop. Okay, and if like no, if not, we have to see the int z idx. Okay, so we have to find the current position of this 0, current position of 0 in that we stored in this one. Okay, okay, let's store on this one. So we have to see what is the next 0. Okay, where is the next 0? So next 0 is equal to current position plus 1 that is less than 0 dot size. Okay, so that one, that gave me a 0 of current 0 plus 1. Okay, otherwise n. Okay, so what is the minimum 0 we require? So mean 0, mean 1 is like, mean 1 is required is like z into z. This is the minimum, and we see int current 1 is equal to z idx minus I plus 1. Okay, and int max 1 is equal to next, and next 0 minus 1 minus I plus 1 minus z. Okay, so if we see that if max 1 is less than less than mean 1 required, then continue this condition. Okay, okay, and what are the needed one is equal to max of that 0, mean 1 required. Okay, and if valid at point, so like next 0 index minus 0 index. Okay, okay, and if this is like a valid endpoint, give it valid endpoint. Okay, this valid endpoint, so in that, if greater than 0, so in that end total count plus is equal to valid endpoint. Okay, and we have to return the total count for this one. So this is like this question is a little bit tougher side as compared to a previous question. So if you don't, if you not understand this question, so I will give you one solution in which I use DP first for the saving the time. So okay, so here is the DP solution for this one. So here you can see here. So first of all, you have to find the size. Okay, this is clear. So you have to create the DP. Okay, size of n plus 1. Okay, first of all n. So I starting from n1 if I is equal to 0. Okay, or as of I minus 1 is equal to 0. So in that case, you have to store that index of 0. Okay, so I created that array. Okay, dominant one, see the example. I have to see this example what we have earlier, this this 30 1. We are with the array with 3011 and 1 and 1. Okay, this is the array we have. This is a substring. So 0th index, 1 index, 2 index, 3 index, 4 index. Okay, so first of all we are seeing that first So all are minus 1. So dp of I plus 1, dp of I plus 1 is equal to 1. So in that case, I have to uh, mention that in there. Else dp of I is equal to dp of I. Okay. So starting from this one, if I is equal to 0, so if I is equal to 0, or in that case, I have to put this one. Okay. So I can go one index. Say I minus 1 is equal to 0. So in that case, dp of I index is equal to 1. Okay. If it 2, then we have to 2. Else, this is minus 1 still. Else case, dp of I plus 1, dp of I plus 1 is equal to dp of I. That is dp of I. dp of I plus 1 में dp of y का content. So this is 2. Okay. So this is how we fill a dp array. So this is a dp array we have. Okay. We find the result. So starting from the ith index, we have to see in this thing. We see in this. This is 1, 2, 3, 4. So this we will say 1th index. So like count, first of all count how we increment. So s of I, the string s of I minus 1 is equal to 0. In that case, I use count is equal to 1, and j become I. Okay. If j is greater than 0 and this count is like count in into is less than n. Okay. Less than n. So count of 1 is equal to I minus dp of j minus count of something. And if its count is 0 is less than count of 1, so in that case, we have to return the minimum of this value. Okay. Now j is updated and then count plus plus. Okay. Count plus plus. And after that, finally we have to return this result. Okay. So this is the DP approach for this question. Okay, this one is like I consider as a hard question, so you have to try from your side. Okay, and see this one. Okay. So thank you for joining this lecture. Okay, bye bye.